guys, good morning. This is actually our last section in chapter 4. So because we just took the 4.3 to 4.6 quiz, which was a very big quiz with some very long topics on it, the way that I'm probably going to end chapter 4, and I apologize, I don't mean to, bombard you with quizzes, but I made a homework for today on 4.7. I just made one. So I'll probably do notes with you today and tomorrow, but the homework will count for both of those sections. And then I didn't make it due until Friday night, so you'll have until Friday night to work on those problems. And then over the weekend, I know, don't get mad, I'm probably going to give you like a 5-question quiz. I may open it on Friday and leave it open till Sunday just to kind of end chapter 4, and then we can come back next week and start chapter 5. So just like a short one section, just a few questions to kind of end it, and then we can move on to chapter 5, okay? And I feel like based off what we've been doing, this is actually a little bit of a breath of fresh air. It's a very, methodical process, but it's not like super, super long for a lot of them, okay? All right, so here we go. So the last section is 4.7, solving polynomial and rational inequalities. So it's pretty natural that after we've seen all of these equations that we move on to their inequality versions now. All right, so just remember, the higher degree the polynomial gets, the more turns and changes, more peaks and valleys that can be created, and therefore the graph can cross over the x-axis more times and have that y-coordinate change sign. So when we solve these polynomial inequalities, the thing we really want to do first to kind of get a starting point is you want to compare the inequality to 0. All right, put 0 on one side of the inequality, get everything else to the other side, because 0 is that cutoff guy between a positive and a negative output. So we kind of use that to get the problem started. Get it compared to 0, and then we'll deal with it from there. All right, so here we go. Guys, we've already solved quadratic inequalities back in section 3.5, or maybe it was 3.6, I'm not sure, because our book changed a little bit this year. But we've already solved this. I had you compare it to 0. I had you guys factor it, find the zeros, and then I gave you 2 options. You could use the graph to tell you where the x values made the graph positive or negative, or you could use something called a sign analysis, and you had to pick an x value in each interval and test it to see if it made the inequality true. So with these ones, I normally just go right to the sign analysis, only for the fact that, guys, we're going to be dealing with rational inequalities. Do you want to really quick rip up a rational graph with asymptotes and holes and all that good fun stuff? No. So because we probably won't want to graph all of these problems, let's just stick with the more algebraic approach and use our sign analysis, okay? All right, here we go. Let's look at problem number 1. I just want to move mine up so I have room. It's not written down on mine, so just give me a second. Okay. So guys, our job is to find all the x values that are going to make this statement true. What x values are going to turn this into a number that is greater than 0? That's our job. All right, so first, we would compare it to 0, but we're good. Then we would factor it. We're good. So now we just have to find the zeros. I guess I shouldn't underline that. What are the numbers that are going to make this number actually be 0? All right, and then we can figure out where it's greater or less than 0. So obviously, if x is -3, it's going to equal 0. And if x is 1, but technically it's a double root because there's 2 factors of that. I just like to make note of it in case you ever want to look at the graph. All right, so these are the numbers that are going to physically make this expression equal 0. So now what you do is take the numbers that are going to make it equal 0, throw them on a number line. All right, now you want to ask yourself, we're trying to get this to become a number that is greater than 0. These are the numbers that are going to make it equal 0. So do I want to include them as answers? No. So let's put open circles to remind us that I don't want to include these numbers in my answers in any way, shape, or form, because these numbers are going to make it equal 0, and I only want to make it equal a number bigger than 0. Okay. So now the algebraic way to solve this is we're going to use a sign analysis. We're going to pick one number in each interval of x values and figure out if it makes the inequality true. All right, so what numbers do we want to test? I'm going to test -4. Obviously, you can test any number you want out here. -50, -100, you do you. All right, so if I plug -4 in, remember, it's called a sign analysis because we really don't care what number it becomes. I care what sign it becomes. So if I plug -4 in, -4 plus 3 is going to be a negative number. -4 minus whatever squared is always going to be positive. So that's going to become a negative number times a positive number, which will end up being a negative number. Is a negative number going to be greater than 0 and make this statement true? No. So this is a bad interval of x values. Those are not x's that are going to make this problem true. All right, let's go to the next. Now I'm going to test, give me a number in here that's probably easy to work with. I'm going 0. So now if I test 0, 0 plus 3, positive. 0 minus what squared? Always positive. So a positive times a positive will end up being a positive number. Is a positive number going to be a number greater than 0? Yeah. So these are good x values. These are going to make our inequality true. All right, let's go to the last interval of x values. What about x values over here? Pick one. I'll do 2. Now, just to give you a hint, right now, these were negative numbers. These were positive numbers, so they were good. 1 was a double root. So that means the graph should bounce in the direction from which it's coming and stay. So he should stay the same sign because he was a double root. It still should stay positive. But I'm OCD, I like to see it for myself. I want to test it. All right, so 2 plus 3, positive. 2 minus whatever squared, always positive. A positive times a positive is definitely going to end as a positive number. And is a positive number going to be greater than 0 and make our inequality true? Yes. So these are also good x values. All right, so now we know the x values that work and the x values that don't. All you have to do is physically name the good x values. I'm pretty sure they ask for interval notation, all right? So interval notation, what intervals of x live here? Well, -3, but not including him, all the way to 1, but not including 1. And then what x values live here? Union, pick up on the other side of 1, because we want to make sure 1's not included, and then we'll go off to infinity. And those are the x values that are going to make this inequality true. Guys, thumbs up. Do you remember doing this a little bit with those quadratics before? Okay. So again, with the quadratics, I had you guys do this because it was so easy. I said, guys, find your zeros, throw them on a graph, remind yourself that they're not included because of that symbol right there, and then let the graph tell you where the positive and negative y values were. Well, these are polynomials. Their graphs aren't always going to be super easy to put together. This one is not too bad. If I multiplied it out, it would lead with a 1x to the third, which is odd, so different end behavior. Leading coefficient is 1. It would be up on the right and down on the left. So it would be up to the right of the last 0 and down to the left of the last 0, and then I could fill the graph in accordingly. Cross, bounce, and up. And again, you can see these x values make a negative number. They're not greater than 0. They're not good. These x values make a positive number come out, which will be greater than 0. These x values make a positive number come out, which will be greater than 0. So you can still use the graph over the sign analysis. However, not all of these graphs are going to be easy to put together. So I want you guys to just remember, it may actually be quicker just to whip up the sign analysis, okay? But on your homework, to begin, they're just going to give you an already graphed polynomial and ask you to figure out where's it greater than 0, where's it less than 0. And then you could just use the graph to get you started, okay? All right, let's try another one. Okay, first things first. This is a degree 4 polynomial inequality, right? Degree 4s can turn up to 3 times, right? They can have lots of changes between the x-axis crossing it and whatnot. So first thing we're going to do is compare it to 0. So let's bring the x over. Now we're going to try to find his zeros. I'm going to hope this is a degree 4 polynomial that I can factor and not have to use my p's and q's on. All right? They definitely have a GCF of x. Okay? And then if I look here, guys, this is the difference of 2 cubes. So I can factor that using the difference of 2 cubes formula, right? A cubed minus b cubed, always factored to a minus b, right, the same sign, times a squared plus ab plus b squared. Sign was the opposite. All right, so x times is going to factor to a minus b. Well, the cubed root of each one of them is x and 1. So that's the a minus b part. And then a squared would be x squared. Opposite sign, a times b is x times 1, which is x. And then b squared, we is 1 plus 1. And then again, greater than or equal to 0 still. All right, let's find our zeros, right? I would look to factor this again, but I know that the difference of 2 cubes always leaves you with an unfactorable quadratic. So I know this isn't going to factor. I'm going to have to use the quadratic formula to find those last zeros. All right, here we go. So I'm going to get x equals 0 as one of my zeros. I'm going to get 1 as one of my zeros. And now let me use the quadratic formula to figure out my last 2 zeros. X will equal the opposite of 1 plus or minus the square root of 1 squared minus 4 times a times c all over 2a. Well, guys, some good news coming our way. 1 minus 4 is going to leave us with the square root of negative 3. So that means our last 2 zeros are imaginary, which don't actually become x-intercepts. So now I don't even have to worry about those 2 zeros. I just got to worry about my 0 and my 1. So take your 0 and your 1, stick them on a number line. Now ask yourself, do I want to include these numbers as solutions? These are the numbers that are going to make this expression equal 0. Do I want to equal 0? Actually, I do. I want to be a number that is greater than or equal to 0. So since I'm allowed to equal 0 here, I want these to be included in some way, shape, or form as my answer. So let's put closed dots to remind ourselves that they have to be part of our answer. All right, let's start testing. Now again, you can test using this expression. You can test using this expression. You can test using the original expression, whichever one you feel easier. I actually feel that this one is the easier one to test with. So I'm going to use this one to test. All right, so I'm going to test negative 1. All right, negative 1. If I plug a negative 1 in, clearly that'll be a negative number. Negative 1 cubed will stay negative, and then on minus 1, it'll still be negative. So a negative times a negative is going to end up positive. Will a positive number make this statement true and be greater than or equal to 0? Yeah, these are good guys. We're going to hang on to those x values. All right, let's test another number. Well, in between 0 and 1 doesn't give you a lot of options. I'm going to go with probably my favorite, a half. 0.5. All right, well, if I put 0.5 there, that's clearly positive. Right? 0.5 cubed will be like what? An eighth? An eighth minus 1 is definitely going to be negative. A positive times a negative is going to be a negative number. And will a negative number make this true and be greater than or equal to 0? No, these are bad guys. All right, and then last. Now again, hopefully you'll start seeing that, guys, none of these were even roots, right, where they had a multiplicity of 2 where it would bounce. So since they were all odd, it should change each time. There's nothing that's bouncing and staying in the same, positive or negative area. So just to kind of give you a clue, because none of these were even multiplicity, if this was, let's say, positive, then this one should cross and this one should be negative. Since this one was an odd multiplicity, it should cross and now be back to positive. There's nothing that's bouncing here and keeping it down there. So use that as clues that might help you not have to test things. I'm always going to test, though, to show you. All right, and then I'm going to test 2. All right, clearly if I plug 2 in, that's positive. 2 cubed is 8 minus 1, that's positive. A positive times a positive will be a positive number, and will that make our statement true and be greater than or equal to 0? Yes. So now we're back to good guys. So now all we have to do is name what intervals of x are the good guys. So now our solutions are going to be negative infinity to 0, including 0 though, so make sure you use brackets. Union, these are all bad guys. I'm going to pick back up at 1, including 1, and then I'm going to shoot off to infinity. And then we're good. Are we okay? Yes, are we okay at home? Good? Thumbs up? All right, perfect. Yeah, I'm just going to try to keep getting through as many examples as I can. Guys, I apologize. I keep seeming to have all the examples that are asking for numbers to be greater. There are going to be problems that ask them to be less than 0 as well. All right. So guys, here is a rational inequality. So I don't know about you guys, but I don't want to whip up that graph. I don't want to find VAs and holes and all that horizontal stuff and figure out what's doing what. I'd rather just use my sign analysis and let the numbers show me what's going on. All right, so here we go. There's a couple things you have to watch out for, though, with the rational, the fraction, right? So the first thing I would do is have you compare it to 0. We're good. Then we would factor it. So let's do that. Difference of 2 squares. Then I would have you find the zeros, just like we were doing, right? Find the zeros. All right? Technically, when you find the zeros of a fraction, you're only setting the top equal to 0. When you cross multiply, it's really only the top that ends up getting you those x-intercepts. So what's going to happen when I set the top equal to 0? I'm going to get x equals 1. So he's going to be my only 0, my only x-intercept. Okay, time out though. Because this is a fraction, we have a domain problem. Polynomials are supposed to have domains of all real numbers. Nothing's supposed to affect it, right? But a rational definitely has numbers that's not in his domain. So now I want you to find the domain. What numbers is x not allowed to be? He's not allowed to be -2. And he's not allowed to be 2. So now when you go to put your number line up, all of these numbers have to make it onto the number line. They're all what we call critical numbers. They all could affect the graph in a critical way. So what we're going to do is the 0, when you put them on your number line, what do we got? -2, 1, and 2. When you put them on your number line, your zeros, you might be allowed to include them as answers. I want to be greater than or equal to 0. So if he's going to make this equal 0, I want to include him. But no matter what that symbol says, equal to or not, I never want to include these numbers. So these numbers always have to stay open circles because they're numbers that we would never plug into this function. All right, and now we just start testing. Now I have 4 intervals to test those. Let's get working. All right, I'm going to test -3 and see what we get. All right, so -3. -3, it doesn't matter whichever one you want. -3 minus 1 is going to be negative over -3 plus 2 is negative. -3 minus 2 is negative. That's going to be a negative over a positive. What's a negative over a positive going to end up as? A negative number. And is a negative number going to be greater than or equal to 0? No. So these are bad guys. All right. Now let's try, where are we at? -2 and 1, let's try 0. All right. 0 minus 1, negative. 0 plus 2 is positive. 0 minus 2 is negative. So that's going to be a negative over a negative, which is going to end up positive. Will a positive number make this true and be a number greater than or equal to 0? Yes, these are good guys. All right, now again, none of these were multiplicity 2. None of them were bounces. So you see how this should be a cross. It should cross again and change sign. As long as we don't have bounces, it should keep changing sign in each interval. But again, I like to test and see it for myself every time. All right, I'm going to try 1.5. All right, 1.5 minus 1 is positive. 1.5 plus 2 is positive. 1.5 minus 2, though, is negative. A positive divided by a negative is going to be a negative number. And will a negative number be greater than or equal to 0? No, bad guys. Because again, if these were positive, this should be a cross, and we should be down to a negative part of the graph now. And then last, I'm going to test 3. But again, we know this was not a bounce, so it should cross and go back to a positive. All right, we're going to get 3 minus 1 is positive, positive, positive. Positive over a positive is going to be a positive number. And will a positive number be greater than or equal to 0? Totally. These are good guys. So now all we have to do is name those good intervals. What are the intervals of x that made this inequality true? These guys from -2 to 1, not including -2, but including 1. And then union, we didn't pick back up until we got to 2, but we don't include 2, and then we go all the way to infinity. And those are your good x values. Does this make sense? Are you okay? Guys at home, are we okay? Okay, I only have a few minutes left. I want to get you started on the next one just to get you to a certain point, and then I can finish it and send you a picture. Just want to show you one other thing that could happen that we haven't seen yet. Well, not on this kind at least. So this one's got a little bit of everything. We've got an unfactored, we got something factored. We're not compared to 0 though, and this is a fraction. So these ones just they get to be annoying, really. We want to get it compared to 0, so let's minus the 3 over, which creates this. Okay. Well, guys, because we need it compared to 0, we also need this to be one cohesive polynomial. And since this is a rational, I'm going to have to find a common denominator to make this become part of his top and bottom. So what's a common denominator? I'm going to have to actually subtract these fractions and make them become one fraction. What's a common denominator between x plus 2 squared and 1? X plus 2 squared. So I got to times top and bottom by x plus 2 squared. Now your denominator, there's no reason to have to FOIL that out because I'm going to factor it eventually, and then once the common denominator, I don't actually end up multiplying these together. We just keep that common denominator. But I am going to have to subtract my top to become one polynomial, so we are going to have to multiply all that out. So let me do this. Let me FOIL this out. X squared plus 4x plus 4, okay? I have a common denominator, so in reality, I'll be taking this, subtracting 3 times that, and then it'll be all over my common denominator. So I'll have 3x squared plus 13x plus 9, subtract 3 times all of that, and then it's all going to be over that common denominator that we got, and now it's less than 0. So you have some work on the top. We want to distribute and combine like terms. So when we combine like terms, you actually get something fairly simple. They actually cancel. 13x take away 12x is 1x. Positive 9 and minus 12 is minus 3 all over x plus 2 quantity squared less than 0. So it becomes that problem right there. And now we're back in business. Let's find our zeros. Let's find our domain. Let's throw them on a number line, and let's start testing the crap out of this. All right, so my 0 is just going to be when x is 3. My domain is going to be x cannot be negative 2, but how many times can he not be negative 2? Twice, which means, again, that VA, they go off to the same infinity, so it shouldn't be changing sign. It should be like a bounce there, if you will, okay? Let's throw them on a number line. Now, who do I want to include? Who do I not want to include? I never include my domain, so always open. My 0 depends on the symbol. I want this to become a number less than 0, but not equal to 0. So now I can't include him either. And now we just start testing, okay? All right, I'm going to stop there because I'm pretty sure, could I do it? Could I do it? Let's do it. All right, here we go. Let's plug in negative 3. All right, negative 3. Negative 3 minus 3 is going to be negative. Over anything squared, we know is going to end positive. So a negative over a positive is a negative number. Is a negative number going to make this true and be less than 0? Yeah, it is. These are good guys. And this is what I'm talking about. See, this would be a bounce. So if he's good and it's negative, then this should stay negative. It shouldn't change sign on the side of that double root there. But I like to test anyway. I'm going to do 0. All right, 0 minus 3 would be negative. Over anything squared is positive. So a negative divided by a positive is a negative number. Will a negative number make this true and be less than 0? Yeah, it will. So these are good guys. And then the last, I know this is a single root, so it's going to cross. So if it's coming from the negative, it's going to cross. This should be positive now. But I'm going to test it anyway. 4. Right? That's going to be positive. 4 minus 3. Anything squared is positive. A positive over a positive is a positive number. Is a positive number going to make this true and be a number less than 0? No, it's not. These are bad guys. So now the only good x's are here and here. So basically it's anything to the left of 3, just not including negative 2. All right, so how do we name that? We're going to say negative infinity to negative 2, but not including negative 2. Union, pick up on the other side of negative 2 and go to 3. But not including 3 either. Okay? Guys, I know that was long, but like I said, I just try and show you all these different scenarios to hopefully prepare you better for the homework, okay? So like I said, I only made one homework assignment for this section, and it's not due till Friday, so you can kind of work on it as you go through. Tomorrow I'll try and go over maybe another scenario with you, but that's it, all right? We're working on this until Friday, okay? All right, if you have any questions, please reach out to me. Have a great